Welcome back, everybody, for another deep dive. This time, we're going to be looking at quantum computing.
Quantum computing, yeah.
You know, it's the tech that's supposed to change, well, everything.
Right, everything, exactly.
How we design drugs, the materials that our world is built on. I mean, it's hard to tell what's real and what's, just hype.
Yeah, it's definitely a very hyped field.
So are we really on the verge of this quantum revolution, or are we getting a little ahead of ourselves?
Well, I think that's the million-dollar question. And the truth is, somewhere in between, those extremes, what's really fascinating is that companies like Google, Amazon, and Microsoft are all kind of racing towards this quantum future, but they're taking very, very different paths.
Yeah, and that's what I love about this whole topic. It's like watching a high-stakes science fiction movie unfold, but it's happening like in real time.
In real life.
So okay, let's start with the basics, for our listener.
Yeah.
Quantum computers aren't just, like souped-up versions of our laptops, right?
No.
It's not just that they can do things faster. There's something fundamentally different about how they work.
Absolutely. Imagine you're trying to cross a vast ocean, okay? A classical computer is like a car. It can speed along the coastline, but it can't actually cross the water. A quantum computer, on the other hand, is like a boat that's built for that very purpose.
Right.
It uses completely different principles to navigate a different kind of terrain, a terrain of complex problems that our classical computers, they can't handle.
Okay, that's a really good analogy. I like that. So to stick with that, Google just sailed their quantum boat into uncharted territory with this Project Willow.
Yeah.
They're claiming that they've achieved beyond classical computation. So what exactly does that mean, and what makes it so significant?
So it's really about capability, not just speed. Okay, so they use this benchmark called random circuit sampling, which is kind of like simulating the results of, let's say, flipping a coin millions of times. Now, a classical computer can do that, but it takes a long time, right? Google's quantum computer, it did it in 5 seconds, while the world's most powerful supercomputer would literally take longer than the entire age of the universe to do the same calculation.
So that's a pretty serious flex, it sounds like.
Yeah.
But does this mean that our laptops are about to become obsolete? Are we all going to have quantum computers on our desks anytime soon?
Not quite. Quantum computers, they're not meant to replace our classical computers. They really excel at very specific types of tasks, like simulating quantum systems, which is just impossible for even the most powerful classical computer. It's kind of like comparing a hammer to a screwdriver. Both are tools, but they have very, very different uses.
Okay, so they're more like specialized tools for tackling like very specific challenges.
Exactly.
So what kind of real-world problems could this quantum boat help us solve? What are the applications here?
Well, one of the most exciting areas is drug discovery. Imagine being able to simulate the interaction of molecules at an atomic level, seeing exactly how a drug binds to a protein. Now, that's a quantum problem because the number of possible interactions explodes exponentially with each atom you add, and it quickly overwhelms even the most powerful classical computers.
So it's like trying to solve a giant jigsaw puzzle with like billions of pieces.
Exactly. But quantum computers, they can handle that complexity because they leverage these principles of superposition and entanglement.
Okay.
Think of qubits, the building blocks of quantum computers, as being able to be in multiple states at once, like spinning a coin and it's both heads and tails simultaneously until you stop it.
Oh, wow.
This allows them to explore many, many possibilities at the same time, making those really complex calculations possible.
That's mind-blowing. So does that mean that like we're on the verge of cures for diseases that we consider incurable today?
Well, the potential is certainly there, but there's a catch. Qubits are extremely delicate, very prone to errors. Think of them like a house of cards in a hurricane.
Okay.
Even the slightest disturbance can cause them to flip their state or lose their delicate entanglement. It's kind of like a dropped phone call ruining an important conversation. And this introduces errors that can cascade and make the results, unreliable.
So it's not just about building these powerful quantum computers. It's about making sure they can like hold a stable thought, so to speak. How are researchers trying to like tackle this error correction problem?
Well, Google's approach with Project Willow it's quite ingenious. They're essentially creating teams of qubits, so combining, nearly 100 physical qubits to create one more stable logical qubit.
Okay.
It's kind of like having a group of people double-checking each other's work to catch and correct any mistakes.
But why does it take so many physical qubits to make one reliable one?
Well, that really gets to the heart of the challenge. The quantum world is inherently noisy and very prone to interference. Even tiny temperature fluctuations or stray electromagnetic fields can disrupt those delicate qubits.
Right.
So you need this redundancy, this teamwork to create a more robust system.
So it sounds like building a quantum computer is as much about controlling the physical environment as it is about the computation itself. It's a whole new level of engineering.
Oh, yeah, absolutely. It's a huge challenge. It is, yeah, and it's really fascinating to see how different companies are tackling these challenges. So while Google is focused on building these teams of qubits, Amazon is taking a totally different approach with their Ocelot project. They're using what they call cat qubits.
Okay, hold on. Cat qubits, like named after Schrodinger's cat.
Oh.
Are they stuffing kittens into quantum computers?
Not quite. It's a nickname inspired by that famous thought experiment where the cat in the box is both alive and dead until you actually observe it.
Right.
Cat qubits are a type of qubit that leverages this whole idea of superposition to be inherently more stable and less prone to those bit flip errors that we were talking about earlier.
Okay, so instead of building like teams of qubits to kind of fight errors, Amazon is creating these super stable qubits right from the get-go. It's like, I don't know, choosing a different breed of dog for a very specific job.
That's a great analogy, yeah. And Amazon has taken it a step further. They've actually managed to link multiple cat qubits together, creating this system that's even more robust. It's a significant leap forward in error correction.
And we've got Google with their teams and Amazon with these super stable cats.
Yeah.
What about Microsoft? Are they in this quantum race too?
Absolutely, yeah. Microsoft is betting on something called topological qubits, which are based on these very elusive particles called Majorana particles.
Okay.
Now, these particles they're fascinating because they are their own antiparticles, meaning that they have this inherent stability.
Wait, their own antiparticles? What does that even mean?
Yeah, it is a bit mind-bending, but imagine a particle that's both itself and its opposite at the same time.
Wow.
This makes them incredibly resistant to external interference. It's kind of like having a shield that deflects all those pesky disturbances that cause errors in other types of qubits.
So if they can crack this, Microsoft could have the most stable quantum computers out there.
Theoretically, yes, but there's a huge if here. The existence of Majorana particles hasn't been definitively proven yet.
Okay.
So Microsoft's approach is it's a high risk, high reward kind of gamble.
Yeah, it's like they're searching for this mythical beast
Yeah.
that could be the key to quantum supremacy, but if it turns out to be just a unicorn, then they're kind of out of the race.
Exactly. And that really highlights the very dynamic and ever-evolving nature of this field. It's still really early days, and there are many different paths to explore, each with its own set of challenges and potential rewards.
Right. So with all this really exciting research and all these different approaches, the big question, of course, is when can we actually expect quantum computers to make a real difference in our lives? When will we see, those cures for diseases, those new materials, maybe even those unbreakable codes that everybody's talking about?
Yeah, predicting the future is always tricky, especially in a field as complex as quantum computing. Some experts, including folks at Google and Microsoft, they're very optimistic. They're claiming practical applications within the next decade or so. Others are a bit more cautious. They're suggesting it could be decades before we see kind of widespread use.
Okay, so it's a waiting game, but it's definitely a fascinating one to watch. But let's be honest here. Are we really talking about quantum-powered smartphones anytime soon?
Probably not in the next few years, but what's really interesting is that, we might not even need to wait for fully fledged universal quantum computers to see some real-world benefits. Even smaller scale, specialized quantum devices, they could have a pretty significant impact.
Like what kind of quantum light applications could we see in the near future?
Well, one area is optimization. Think about, let's say, traffic flow in a city or optimizing logistics for global supply chains. These are incredibly complex problems that classical computers struggle to solve efficiently, but even smaller scale quantum computers could make significant improvements.
So less about, teleporting cars and more about making our commutes less soul-crushing. I'm
Exactly.
all for that.
Yeah, it's about finding ways to apply these quantum principles to real-world problems that impact people's daily lives even before we have those massive world-changing quantum computers.
Yeah, that makes a lot of sense. So it's not just about the big breakthroughs, it's about finding those practical applications along the way. But let's not forget about the big picture here. We've talked a lot about the technical side of things, but what about the ethical and societal implications of this technology? It's not all sunshine and roses, is it?
Yeah, you bring up a really important point, the power of quantum computing. It raises some very profound questions. For
Yeah.
example, if we can simulate molecules to design these new drugs, who gets access to those drugs? Will they be affordable for everyone? And what happens if quantum computers become so powerful that they can crack the encryption that protects, our online transactions, our personal data, our entire digital infrastructure?
Those are some pretty serious concerns. And it sounds like we need to start thinking about this now before this technology gets out of hand.
Absolutely. We need to have a real societal conversation about the responsible development and deployment of quantum computing. It's not just about the technology itself, it's about the kind of future that we want to create with it.
So it's not just about the bits and the qubits. It's about values and ethics.
Exactly.
It's about making sure this incredible technology serves humanity and not the other way around.
Well said. It's very easy to get caught up in all the excitement of scientific progress, but we can't forget that bigger picture. Quantum computing has the potential to really reshape our world, and it's up to all of us to ensure that it's a positive transformation.
And that includes our listener. We've thrown a lot of information at you today. So I'm curious, what's standing out to you so far? What are your biggest takeaways or maybe your biggest questions?
It's it's really incredible to think that, we're living through a time when something as mind-boggling as quantum computing is actually becoming a reality. It's like science fiction is literally coming to life right before our very eyes.
Yeah, it really is a remarkable time to be alive.
Yep.
And I think it's important to kind of step back for a second and appreciate the profound implications of this technology. We're not just talking about faster computers. We're talking about machines that operate on principles that challenge
Right.
like our very understanding of the universe.
Right,
And
exactly.
it makes you wonder, like, what happens when we have access to computational power that can, like, simulate nature at its most fundamental level? What secrets of the universe might we unlock?
I mean, it opens up possibilities that we can barely even imagine today. Imagine being able to design new materials from scratch, atom by atom, creating substances with properties that defy our current understanding of physics.
Yeah.
Or what about simulating the human brain, leading to breakthroughs in artificial intelligence and maybe even a deeper understanding of consciousness itself.
It's both exhilarating and a little bit terrifying, isn't it?
Oh, absolutely.
The potential is enormous, but so are the risks.
Absolutely, and that's why it's so crucial to have these conversations about the ethical implications of quantum computing. We need to be thinking about how to ensure that this technology is used for good, that it benefits humanity as a whole and doesn't exacerbate existing inequalities or create new ones.
It's like we're standing at a crossroads. Quantum computing, it could lead us to a brighter future, a future with solutions to some of our most pressing challenges, from disease to climate change. But it could also lead us down a darker path, a path where this incredible power is concentrated in the hands of a few, used for control and exploitation rather than for the betterment of humanity.
Right. And the choices that we make today, the conversations we have, the policies we put in place, they're going to determine which path we take.
So it's not just up to the scientists and the engineers to figure this out. It's up to all of us.
Exactly. We need a society-wide discussion about the values and principles that should guide the development and deployment of quantum computing. We need to ask ourselves some really tough questions. What are the potential benefits? What are the risks? Who will benefit and who might be left behind? How do we ensure fairness and transparency and accountability.
It's a huge responsibility, but also an incredibly exciting opportunity. We have the chance to shake the future of this technology, to ensure that it's used to create a world that is more just, more sustainable, more prosperous for everyone.
Well said. And I believe that by engaging in these conversations, by being informed and proactive, we can harness the power of quantum computing for good. We can unlock its potential to really solve some of the world's greatest challenges and create a brighter future for generations to come.
That's a really hopeful note to end on. And I want to thank you, our listener, for joining us on this deep dive into the fascinating and ever-evolving world of quantum computing. It's a journey that's just beginning, and we're so excited to see where it leads us. Until next time, keep exploring, keep questioning, and keep those quantum minds engaged.